right? Then you know that previously also I told you, give me one second, right? You have discussed all the things from this complex numbers lesson with Kasim Madam, and I just recall your memory about the topics of these complex numbers. You have done the operations with complex numbers as addition, subtraction, multiplication, division, like real numbers, right? And you have learned about complex conjugate, and you have learn about the De Moivre's theorem in complex numbers, right? So these are the main things that we have to learn about complex numbers. Actually, they are very interesting lesson, I think, complex numbers are. So let me start the first question here. You can say this one, complex. The first question given that is that equals square root 3 minus I, right? So you know that in a complex number we have two parts, imaginary part and the real part, right? And here it is given that Z star is the complex conjugate of Z. Right, so first you have to show that the division of these two complex numbers is given result here. Z over Z star is equals to half minus square root 3 divided by 2i, right? So this is the result that you have to be shown here, right? Okay, then we'll start. Let me share the whiteboard. Let me share the whiteboard here. Right. This is the first question we have. Tutorial 5, first question. The complex number Z is given like square root 3 minus I, right? So it is given that Z star is the complex conjugate. You know the idea of this complex conjugate. That means if the complex number is given like A plus BI, complex conjugate becomes A minus BI, right? So this is the main idea of this complex conjugate. So according to our example, we can write this Z star as square root 3 plus I, right? So you have to change the sign of the imaginary part of this complex number, right? So here, then in the first part of this question, it is asked to show, it is asked to find that Z over Z star, right? So you can see is now we have already have these two values, complex number Z and Z star. So it is this one, right? So the question, it is given this complex number. You know that division between two complex numbers gives you another complex number, right? So you have to convert this one to A plus BI form, right? This form. So you can see here in the numerator and the denominator, you have both I terms here. So you have to do some simplification to make this complex number for this format, right? So you know that if there is a division of two complex numbers, it should be multiplied by the this both denominator and the numerator by the conjugate of this denominator complex number. So you can see, I will write it in second step. Say square root 3 minus I divided by square root 3 plus I is here. So you know that the complex conjugate of this denominator is square root 3 minus I. So we have to multiply both denominator and the numerator by this complex conjugate. This is the simplification that we have to follow in these type of questions, because by using this simplification, we can make our denominator as a real number, right? So අපිට මේකෙදි මේ විදිහට මේ හරයේ තියෙන denominator හරයේ තියෙන complex number එකේ conjugate එකෙන් දෙකම වැඩි කරාම උඩයටයි දෙකම වැඩි කරාම අපිට පුළුවන් වෙනවා මේ හරය තියෙන සංඛ්‍යාව complex number එක real number එකක් බවට convert කරගන්න, right? So because we are doing this simplification for making the complex number in this format, right? So we'll see how to simplify this one. So you can see in the numerator, you have square root 3 minus I to the power 2, right? Because you have to multiply each term here, right? And here you can see there is a two terms like square root 3 plus I and square root 3 minus I. So you can see it is just like the factors of a difference between two square terms. වර්ග දෙකක අන්තරයේ සාධක විදිහට තමයි ඒක තියෙන්නේ, right? So you know that if there is a two factors like x minus y and x plus y, it is equals to x square minus y square. So you have to use the knowledge of this difference between two square terms here, because here also you can see you have factors like square root 3 plus I, square root 3 minus I. So you can use the same result for this one also. That means square root 3 minus plus I, square root 3 minus I. That means you have to use the square term of this first term. That means square root 3 square minus I square, right? So you can see here, square root 3 to the power 2 means it is square root, it is 3, and you know that I square, it is the main concept of this complex number. You know that I square is equals to minus 1, because we define I as the square root of minus 1. So you know that we can simplify this one as minus 1, right? So it becomes minus 1 becomes plus 1. So we can write this one as 4. So you can see by multiplying by the conjugate of this denominator by denominator, both terms, denominator and the numerator, you can make your denominator as a real number, right? So we can apply this one as a 4, right? Then I separately simplify this one and substitute for this one. But if you are doing these things, do not need to work like this roughly. Rough works are not needed in your answers, right? ඔයගලන්ට මම මේක පැහැදිලි කරන්න නිසා තමයි මේ විදිහට දීලා පෙන්නන්නේ. So in the next step, I'm going to expand this binomial. So you can see there is a square term of this binomial. So first thing you have to do is take the square term of this first term. So it is 3. And the twice of the multiplication of these two terms, so we can take this one as 2 square root 3 I and plus I square, right? So the denominator we have 4. So you can see here we can simplify this one also, because I square is minus 1. So here we have another real number like 3. So 3 minus 1, it gives you, I will delete this one. 3 minus 1, it gives you 2. So minus 2 square root 3 I divide by 4. So you can simplify this one as half minus square root 3 divided by 2I. So you can simplify this answer like this, right? So this is the solution that given in the question. We have proved that Z over Z square complex number can be written as in this format, right? Okay, then I think this one is clear for you. Sometimes it is very easy for you, right? But in this part, since it is the very first question of the tutorial, so that's why I explain one by one here. So let me show you the question again. We have to write the yeah. In part B, you have to find the modulus value of this complex number. So you know that it is also very that means very main properties of a complex number, modulus and arc value, right? Modulus value means the length of the, when you are draw, okay, let me share it in the whiteboard, right? You can represent a complex number like we represent real number coordinates and in a Cartesian plane. As well, we have another plane for complex numbers. So it is, we are calling this one as Argand diagram, right? Argand plane. So when you represent some complex number on an Argand plane, so the modulus of this the graphical representation I describe here, modulus of some complex number is the length which has from origin to this complex number, right? So in our question, this is part B, you have to find the modulus value of this Z over Z star. So you know that it is, we have proved that this one is half minus square root 3 over 2i, right? So we have to find the modulus value of this complex number, right? So actually we can draw this, I will explain it by drawing on a Argand diagram. You know that we have x and y axes in Cartesian plane. Likewise, you have a real axis and the imaginary axis in this Argand diagram, right? So this one x-axis called as real axis, and this one is called as imaginary axis, right? So our complex number is half minus square root 3 over 2i, right? So we call this part as x, right? And this one is real part, and this one is imaginary part, right? So we can denote this complex number. You can see the real part is half, right? Half, and the imaginary part is minus square root 3 over 2. So you can mark this one as minus square root 3 over 2 from this way. So we can denote this complex number Z over Z3 here, right? So by the modulus value of this complex number is this length, right? So you know that it is when we get this one as R, right? So we can get you know the lengths of these sides. This one is square root 3 over 2, and this one is half, right? So you can get the R value by taking the by using Pythagoras theorem, right? So it is square root half square plus minus square root 3 over 2 square, right? So this is the way how we get the modulus value, because you know that when you are using this triangle, it is a right angle triangle, so this length is half. So by using the Pythagorean theorem, we can get square root 3 over 2 to the power 2 plus half to the power 2 equals to R square. That's the thing that we have used here, right? So when you are simplifying this one, you can end up with 1 over 4 plus 3 over 4. So the square root symbol is there, and we can simplify this one as square root 1. So it is equals to 1. So the modulus value of this complex number becomes 1 here, right? Then we'll see the next part of this question. And yeah, the next part we have Argand value. So I will explain these things in next part. So in the part C, it is given that verify for z over square root 3 minus I, that arc of this division of these two complex numbers I equals to arc z minus arc z star. So you know that it is a result that you have learned in your lecture. If there is a division of two complex numbers, then we can give the arc values of this division of two complex numbers as the difference, right? So difference of arc values each other, right? It is just like logarithmic rules. The logarithmic rules වලත් අපි මේ වගේ එකක් කතා කරනවා නේද? Division එකක් තියෙද්දි අපිට ඒක difference එකක් විදියට ලියන්න පුළුවන් කියලා. ඒකට ඒ වගේ rule එකක් තමයි මෙතනත් තියෙන්නේ. So you know this rule. So but for this case, for z equals to square root 3 minus I, you have to verify this result, right? So we'll see what is I will explain you what's the arc value first, right? So you know that arc value of a complex number means it measures let me draw the Argand diagram. Right, so this is the real axis and this is the imaginary axis. So some complex number is in like this. So you can see the arc value of this complex number is the angle. Arc value means an angle, right? Arc value එක කියලා අපි ගන්නේ කෝණයක්. So arc value is the angle which measures from this real positive real axis from positive real axis to this complex number, right? This line, right? So actually it is this angle is measures anti-clockwise, right? So you know that when you are to treat questions, you get the angles measures in this side. We are taking this one as positive angles because they are measures in anti-clockwise, right? Or right, and anti-clockwise. So we take these angles as positive angles. Here also, just like this, we get arc values from as this just like these positive angles, right? එතකොට අපි arc value එක කියලා ගන්නේ මේ මූල ලක්ෂයයි z කියන complex number එකයි යා කරන රේඛාව මේ real number real line එකේ ධන දිශාවත් එක්ක හදන කෝණය තමයි අපි arc value එක කියලා ගන්නේ. So arc value is the angle which formed by the line connecting the complex number z and the origin form with the positive real axis, right? So you know that so we can say since we know the length of these since we know the if you are take this complex number like x plus iy, right? So you know that this length is x and this length is y. So you can easily get the tan theta value as y over x. So by this one, we can take tan inverse is y over x. This is the case, right? So it's easy for first quadrant complex numbers, right? So when you are getting complex numbers in these quadrants, right? First, that means second, third, and fourth quadrants, right? So you have to just calculate the tan value by using the only the length, right? So I'm taking I will explain this one by this example, right? Example so first we have to verify the solution here. Give me 1 second. Here our z value is I just write the This is our z is square root 3 minus I, and our z star is square root 3 plus I, and z over z star value is half minus square root 3 over 2I. So we in this case we have to prove that arc z over z star is equals to arc z minus arc z star. So this is the result that we have to prove here. Right, before prove the result, I will represent these three complex numbers in this Argand diagram. Here you know that this one is we have already marked in on a Argand diagram, so we can mark this one as like this z over z3 complex number, right? So you know that this one is half, and this one is square minus square root 3 over 2. So we'll see, we have to verify this solution. So we will get this left hand side first, but we have to take the arc value of this half minus square root 3 over 2I, right? So when you are taking the arc value here, so you can mark, you can connect this complex number with this origin, and the arc value of this complex number is the angle formed by this line with the positive real axis, right? May real axis again positive පැත්තේ ඉඳන් මනිද්දි මොකද වාමාවර්ත කෝණය, right? Anti clockwise අපි ගන්න කෝණය තමයි අපි theta කියලා කියන්නේ, right? Theta or the angle, right? Arc value, right? So when you are getting the arc value of this one, but don't use the that means I'm suggesting you that do not use that the same by-hearted formula for finding arc value, right? ඔගොල්ලෝ අර මතක තියාගෙන ඉන්න formula එක නෙමෙයි, just draw the complex number on an Argand diagram, and you can find any value here. It can be I can say this value is alpha, right? So you can easily get this alpha value. It is tan alpha is equals to, you know that tan value, it is taken by the opposite side. This one is half divided by the adjacent value here, right? It is square root 3 over 2. So when you are substituting these lengths, just substitute the value, not the sign. Here you know that this one is minus square root 3 over 2, but here when you are finding the angle, tan angle, so just put only the value here, right? Because we are taking this triangle, right? අපි මේ ගන්න මේ ත්‍රිකෝණයක්, ඒකේ දිගවල minus වෙන්න බෑනේ, right? So just put the value only, right? Then you can take the alpha value as tan alpha is equals to 1 over half multiplied by 2 over square root 3, right? So tan alpha can be written as 1 over square root 3. So alpha can be taken as tan inverse 1 over square root 3. So it is equals to 30. This value can be taken from the calculator, right? So what is the arc value of this one now? You know that we want to find as left hand side of this formula, right? Arc z over z star, right? So it is equals to this angle, this red color angle. That means you have to add this alpha to this angle, right? That means this is 270 degrees, 90 into 3. So it is 270 plus alpha, right? So that's a way how you calculate arc value, right? So you know that you have already found this alpha value is 30. So we can end up with the arc value of this complex number z of z3 as 300 degrees, right? So likewise, you can show that these two right hand side of this formula also is equal to this 300 degrees. We'll see the right hand side of this one also, right? Let me use another sheet here, right? So we have to show that this right hand side is arc z minus arc z star, right? So we can write this one as arc z means square root 3 minus I minus arc z star means square root 3 plus I, right? So when you are draw these two complex numbers, I first take this z, right? I just put this on this Argand diagram, right? So this one is real and this one is imaginary axis. So when you take this square root 3 minus I, right? So you know that square root 3 and minus I, here the real part is square root 3 is positive and imaginary part is minus 1. So we can get this one as, we can represent this z complex number square root 3 minus I like this, right? So this is the complex number z. So when you are taking, someone drop a text. No, it is not. There is no any standard way to write an arc values only on degrees or only on radians, right? So Shaina is asking which units that we have to use for these arc values. That means sometimes in questions it is given that give the arc values in radians. So at these points you have to give your result, that means arc values in radians. But it doesn't matter, units doesn't matter here because it's up to you. It depends on the question and it's about it's depends on your view, right? Okay, then so you know that Z, this is the Z complex number, and what's the arc value of this Z? You have to find this angle, right? So in order to find this angle, you know that you have to take any of these two angles. Sometimes you may get this theta or this beta. It doesn't matter, right? So you can use any of these two angles. So when you are using this theta angle, your arc value is arc Z is equals to 270 plus theta, right? Or you can take arc Z by 360 minus beta, right? It's up to you, right? So you can use any of these results. That's why I told you, do not use the by-hearted formulas for these cases. Just draw the complex number on Argand diagram and do your calculations with your own method, right? So here you can see the tan theta, right? I like to take this theta here. So tan theta value can be written as tan theta equals, that means you have to take this opposite side. The length is square root 3 divided by the addition side, right? So it is 1. Do not take minus 1, right? See, you know that this coordinate is minus 1, but we just take the length. Sorry. We just take the length, it is 1. So theta can be taken as tan inverse square root 3. So it is 60, right? So when you are taking the arc Z, that means you have to substitute this value for this one, 270 plus 60, right? So we can take this one as 270 70 plus 60, it is 330, right? So it is 330 degrees, right? So when you are using the beta angle, someone can use this beta angle as well. Just use one angle, right? Do not need to do your results like this. I just use this beta angle also to show you the same answer comes with these ones also, right? So tan beta can be written as, if someone can use this beta angle to find this, you can find this beta angle like tan beta is the opposite side, it is 1 square, divide by the addition side, it is square root 3. So beta is tan inverse 1 over square root 3, it is equals to 30 degrees. So we can substitute for this one, arc Z is 360 minus 30. It is also given the same result, 330 degrees. So we have found this value as 330 degrees. This is arc Z value, right? So after that, you have to find this arc Z star value also. Give me 1 second, someone drop the text. Anushka is asking something, another question which not relates to this one. So I will answer for your question after this one, Anushka. Right. So we have to find this arc Z star also. Right. So arc Z star, I will use another sheet for this one. You know that arc Z star is square root 3 plus I. Right. So we can draw this one here, square root 3, this is imaginary, sorry, real part, real axis, and this is imaginary axis. So when you are getting Z star here, so this one is square root 3 and this one is 1, right? So when you are getting the arc Z here, you have to calculate this angle. I am taking this angle as theta. So tan theta equals this value, opposite value. So it is 1 divided by the adjacent value. This value is square root 3. This length is square root 3. So we can take this one as 1 over square root 3. So theta is equals tan inverse 1 over square root 3. Right, so it is equals to 30 degrees. So we get that arc Z star value is 30 degrees, right? So we can apply for this result. We found that Z star, arc Z star is 30 degrees. So we can prove that 330 degrees minus 30, it gives you 300 degrees. So we proved that right hand side, that means this value can be simplified as 300 degrees. Previously we have showed that the left hand side of this one, left hand side of this formula is also 300 degrees. We proved in previously. So we can say that right hand side is equals to left hand side. So that means we have verified this result here, right? Is this okay? Is this okay? Is it clear for everyone? We have discussed this part C here, right? If there, Shaina is saying okay. What about others? Oh, others are also okay with this one. We have discussed only 3 parts here. Is it okay? Yes, Nadira is also saying yes, right? Okay. Then we will go for this part D. Find a quadratic equation with root Z and Z star. Risindu is saying last part means the part D. Risindu කියන්නේ part D එකද නැත්නම් part C එකද? Part C, right? Okay, then I will explain it again. Right, right, Risindu, this is the question you have. You have square root. You know that this is the common result that you have learned in your lecture. Arg of some two division of two complex numbers is equals to the separate arg values. Difference of separate arg values. Arg z over z star is equals to arg z minus arg z star, right? So here you have to verify this result for your question. For your question means z equals to minus 3 over, minus 3, square root 3 minus I, right? So let me go for the whiteboard for this one. Right, here. Risindu, we have z is square root 3 minus I. Z star is square root 3 plus I. This is the complex conjugate of this z, right? And we have another complex number by dividing each z and z star. It is half minus square root 3 over 2i, right? These are the three complex numbers we have. By using these three complex numbers, we have to prove the result. Arg z over z star is equals to arg z minus arg z star, right? So when you draw the all complex numbers here, first I want to get the left hand side of this this result, because we have to prove this left hand side is also same as the right hand side, because you have to verify the solution. That means you have to prove this left hand side is also equals to the right hand side. So let me take the left hand side first. Left hand side of this result is arg z over z star, right? So when you draw this z over z star complex number on an Argand diagram, right? So we can take the Argand diagram. We can draw it in the Argand diagram here. This is real axis and this is imaginary axis. So you know that this is our complex number, right? So the real part is half and imaginary part is minus 3 over 2. So when you are drawing this complex number on an Argand diagram, you have to consider this minus values, right? I just told you to neglect these signs when you are taking tan values, because we apply tan values for some triangles. So the sides of the triangle is not a minus value, right? The length of some side of a triangle means it is just a positive value, right? So that's why I told you to take just a value. But when you draw this complex number, when you represent this complex number on an Argand diagram, you have to consider these signs, right? So you know that it is half and minus the real part is half and imaginary part is minus square root 3 over 2, right? So we can represent this z over z star complex number in this coordinate. So half minus 3 over 2. This is the coordinates that we have, and this is the complex number we have, right? So arg value of some complex number is, we have to take this angle. This angle means the angle which formed by this line which connecting the complex number and the origin, measured by this positive real axis. May positive real axis එකෙන් පටන් අරන් මන්නහම මෙන්න මේ කෝණය තමයි arg z කියලා කියන්නේ. මේ arg z over z star කියලා කියන්නේ, right? මේ complex number එක origin එකට යා කරලා අඳින රේඛාව real axis එකේ positive පැත්තේ ඉඳන් මනිද්දි හදන කෝණය, right? So this is the arg value. This is a just simple idea of arg value, right? So when you are taking this arg value, you can take you know that you have to take one of these two angles, right? So when I'm taking this one as this angle is alpha, right? So we can take the alpha angle by tan alpha is equals to I can say this by using this alpha value, we can say the arc value is equals to 360 minus alpha, right? Because we have to subtract this angle because we know we want to get this blue color angle from this one as the arc value. So we have to take 360 minus alpha. So separately we can say, we can find what is alpha here because tan alpha can be written as, because we know these two lengths, this length is square root 3 over 2. So it is equals to square root 3 over 2 divided by the adjacent side, it is half. So we can say alpha is equals to square root tan alpha is equals to square root 3, right? So when you divide these things, and alpha can be written as tan inverse square root 3, it is equals to 60 degrees. So we can substitute this alpha value for this one, 360 minus 60. So it is equals to 300 degrees. So we proved that LHS, left hand side, is equals to 300 degrees. After that, you have to find this right hand side. Right hand side, we have the arc Z minus arc Z star. We have to prove that this result is also same as the 300 degrees, right? So when you take this one, I will use a differentiate. So when you use this one here, we have to prove right hand side is equals to, you know, that it is arc Z minus arc Z star, right? So it is you know that when I draw this one in an Argand diagram, right? So it is this is real part and this is imaginary part. So you know that Z is square root 3 minus I, right? So we can draw this one. This is square root 3, this is minus 1. So we can draw this Z as a square root 3 and minus 1. So this is the complex number Z, right? So we have to take arc value here. That means you have to measure this angle, this red color angle. In order to find this red color angle, we can take you can take one of these two angles. I would like to take this alpha here. Since we use alpha angle, I will use theta here, right? I will use theta here because this arc Z is equals to 360 minus theta, right? May red color angle එක අපිට ගන්න පුළුවන් 360 වලින් මේ theta angle එක අඩු කළාම, right? We can take this tan theta as tan theta, this value, opposite value, it is equals to 1. This value is square root 3. So 1 over square root 3. So we can take this one as theta is equals to tan inverse square root 1 over square root 3. So it is equals to 30 degrees. So we can prove that 360 minus 30 is equals to 330. Right? So this part is okay. And we have to take the arc value of Z star also, right? So arc value of Z star, I will use the same Argand diagram. So Z, this one is square root 3 plus I, right? So this is Z star, it is square root 3 plus I. So when you use this one, so it is 1 and this is square root 3. So you have to take for my simplification, I will use this one, right? So for this one, we have to use arc Z star means you have to take this beta angle, right? I will take this one as beta, right? So we have to take, this is the arc value of Z star, right? Arc Z star is equals to beta, right? So tan beta can be written as, tan beta is, opposite angle is square root, opposite side is square root, sorry, 1. Opposite side is 1 and divide by the addition side, it is square root 3. So beta can be taken as tan inverse 1 over square root 3, right? So it is equals to 30. So we can say this is equals to 30, and 330 minus 30 is equals to 300 degrees. So in the right hand side also, you have proved that it is equals to 300 degrees. So left hand side also we proved that it is 300 degrees. So we can verify this result. What is our result? Arc Z over Z star is equals to arc Z minus arc Z star. This is the result that we have proved here. Right, is it okay, Risindu, now? Okay, Risindu, you are welcome. And we are discussing, now we have to discuss the part D of this question 1. So in this question, you have to find the quadratic equation which with roots Z and Z star in the form of ax square plus bx plus c equals to c. So it is given that the standard format of a complex number ax square plus bx plus c. Right, so you have to find the, you know that you have deal with many quadratic equation in your first lessons, first lesson, initial lessons, right? Fundamental lessons. You have found, you have solved quadratic equations, you have factorized quadratic equations. Like this, you have do many simplifications with quadratic numbers, quadratic equations. But in these cases, the roots of these quadratic equations becomes real roots. Real roots means we can take, we can by solving some quadratic equations, we can get one solution or two solutions. So we can we could get some real values for this as the solutions of this x. The roots means the solutions of some quadratic equations, right? So in this one, it is, let me show it, let me explain more about this one in whiteboard. Wait, right? So you know that if you have a quadratic equation like this, x square minus x minus 6 equals to 0, right? So if you require to solve this equation, right? So if one can use the factorization method, one can use the calculator, and one can use the formula also, right? So when you factorize this one, so you know that you can write this one as x minus 3 x plus 2. This is the two factors of this quadratic equation, right? So you can verify this one, x square minus plus 2x minus 3x and minus 6. So when you are solving this quadratic equation means you are taking that x minus 3 equals to 0 or x plus 2 equals to 0. So x equals to 3 or x equals to minus 2. So these are the terms, these are the solutions of the x values. That means these are the points where this quadratic equation, the graph of this quadratic equation cuts the x-axis. අපි මේවට කියනවා එක්කෝ වර්ගජ සමීකරණයක මූල. නැත්නම් කියනවා වර්ගජ සමීකරණය විසඳීමෙන් අපිට ලැබෙන solutions. නැත්නම් අපි කියනවා ඒ වර්ගජ සමීකරණය, වර්ගජ ශ්‍රිතය x අක්ෂය කැපෙන තැන්. මේ හැම එකකින්ම කියන්නේ මේ ටික. Right, so when you are if you want to repeat this one in this side, that means someone say for you find the quadratic equation which have the roots 3 and minus 2, So how we construct the quadratic equation now? අපිට පුරුදු familiar පැත්ත තමයි මේක quadratic equation එකක් දුන්නාම ඒක factorize කරලා solve කරන විදිය. But someone told you, right, so if someone tell you that 3 and minus 2 are the roots of this quadratic equation, what is the quadratic equation? So this is the type of equation, this is the type of question it is asking this part D. That's why I'm describing. So if someone tell you please construct the quadratic equation here, the thing you have to do is you are telling that x minus 3 x plus 2 equals to 0. This is the way how we construct this one, and we multiply each brackets each other, and we told that x square plus 2x minus 3x minus 6 equals to 0. So we end up with the result x square minus x minus 6 equals to 0. This is the quadratic equation which have the solid roots as 3 and minus 2, right? So we take this action, right? So in this question it is given that අපේ question එකේ දීලා තියෙන්නේ z and z star roots එක්ක quadratic equation එක develop කරන්න. So මෙන්න මේ තියෙන එකම තමයි අපිට කරන්න කියලා තියෙන්නේ. මෙතන පොඩි වෙනසක් තියෙනවා. මෙතන අපේ තියෙන real roots 3 and minus 2. Here we have complex roots, right? So if you are required to develop the quadratic equation here, you have to set up the same method here, right? So since these z and z star are roots of this quadratic equation, means we can write this one as x minus z star equals to 0. This is the quadratic equation we have. Then just put values for this z and z star. You can construct the quadratic equation like this. මේ වගේ quadratic equation එකක් අපිට ගන්න පුළුවන්. Right? So when you are getting the sometimes you can substitute these z and z star values at this stage, or you can simplify by keeping them as z and z star. After that, finally you can use the results, right? So when you are simplifying this one, we can get x square. සමහර අපිට කෙනෙක්ට පුළුවන් මෙතෙන්දී දැන් z and z star ආදේශ කරන්න. එහෙම කළා කරන්නත් පුළුවන්. නැත්නම් තව කෙනෙක්ට පුළුවන් මේක මෙහෙමම තියලා සුළු කළා අන්තිමට again z star and z ආදේශ කරන්න. So I will show you the both methods here, right? So we can expand these brackets like x square, and here minus z star x minus zx plus z star is equals to 0. Right? Now we are constructing our quadratic equation, right? So we can get here for these two terms, we can take x as a common factor. So z plus z star x plus z star equals to 0, right? So we can apply these values for this one because we can found these values. You know that z plus z star is equals to z is minus square root 3 minus I, and plus z star is square root 3 plus I. So we can easily take this I and this I cancel out, and 2 square root 3 is this result, right? 2 square root 3. And z star, we have to take the multiplication of these two values. I will use a different sheet here, right? So when you are taking z star, we can take square root 3 minus I, square root 3 plus I, right? So you have to simplify this one. So when you are simplify this 3 and square root 3 and square root 3, it gives you 3 square root 3 into I, it is square root 3I, and after that you have to take minus square root 3I here, and minus I square, right? So we can take this one as, we can cancel out these two terms, and actually this is the factors of difference between two square terms. So we can take this one as I square. So this one is 3 minus 1. So it is 4. So our result is here, we have proved that this is or is also equals to 4. So our result can be, so we can prove this one as we can fill this result. Z plus Z star means 2 square root 3x plus 4 equals to 0, because we have taken this Z star value is 4, right? So this is the quadratic equation which have the roots as Z and Z star, right? So the same, it is same as the real numbers, right? Real numbers quadratic equation එක build කරන මේ steps මයි අපි ගත්තේ. එතකොට ඒ steps අරගෙන ඔයගලන්ට පුළුවන් ඒ අදාළ quadratic equation එක හදන්න, right? So here the second method is someone can substitute Z and Z star at this stage also. කෙනෙක්ට පුළුවන් මේ විදිහට අවසානයේටම වෙනකන් Z star Z and තියාගන්න නැතුව මෙතෙන්දිම සුළු කරන්න, right? I will show you this step also, right? So you know that Z x minus Z star, this is our result, equals to 0. This is our quadratic equation. So one can simplify this one as square root 3 minus I, right? X minus square root 3 plus I, right? මෙහෙමම තියාගෙන කෙනෙක් සුළු කරන්න පුළුවන් ඒත් එන්නේ එකම answer එක. So you can simplify this one, these brackets like x into x, it gives you x square, x into minus 3 plus I x, and when you are taking this one, right? So it gives you square root 3 minus ix, and you have to take this value also, plus square root 3 minus I square root 3 plus I, right? Equals to 0. So you can get this one x square minus, you can simplify this one by removing brackets here, square root 3x plus, square root 3 x plus ix minus square root 3x minus ix, right? So here you know that the result is 4 equals to 0, because it gives you square root 3 square minus I square. The result is 4. That's why I just put the value for this one, right? So we can get the result by simplifying the brackets. So you know that x square minus 3x minus ix minus 3x plus ix plus 4 equals to 0. So you can cancel out this plus ix and minus ix here. So you can get the same result by taking the two answers here. This square root 3x and this square root 3x gives you 2 square root 3x plus 4 equals to 0. The same quadratic equation can be taken by this one, right? So actually you can verify your solution by giving this quadratic equation for this calculator and take the roots. Then you can definitely, you will get the these complex roots like square root 3 minus I and square root 3 plus I. Do with your own, check with your calculator. This is what is the roots of this square quadratic equation, right? So yeah, it is very interesting, right? So actually, what do you think about the graphical representation of this quadratic equation? Make a graph එක ගත්තොත් කොහොමද? Actually you know that since it is a x square, that means the coefficient of this x square is positive, definitely it is a minimum graph, right? So it is a minimum graph we can draw this one as like this. एक minimum එකක් ඒ වගේම අපි දන්නවා මේකේ x there are no real roots. That means the roots are complex roots. There are no real roots. So the graph does not cut the x-axis at any point. මේ graph එක කිසිම වෙලාවක x-axis එක cut කරන්න බෑ. x-axis එක cut කරනවා කියලා කියන්නේ අපිට මේකේ real roots තියෙනවා. නමුත් අපි දන්නවා මේකේ real roots අපිට නැහැ. That means this graph should be above the x-axis definitely, right? So is it clear for you? This is the end of the question 1, right? We have spent 1 hour for the question 1, right? So is it clear? Is this clear? Or if you want to, I can explain again about this quadratic equation, forming the quadratic equation by using this one. Somebody saying yes. Okay, all are saying yes. So I guess that all are okay with this one, right? Okay, we'll see the next one, next question here. Give me 1 second. Okay, Sandanika is saying yes. Then this is the second question here. Can you see the second question now on the screen? Ashane, can you see the screen now? Second question. What are you doing? All are very silent. Are you sleeping? Otherwise, it will be boring for me also. Please give your comments. Can you see the screen? Fahim? Fahim, smile. Oh, you are dropping messages. Okay, then, okay, let me explain this one here. Right, so the complex numbers Z and W satisfy the following simultaneous equations. So you know that you have discussed about the simultaneous equations in your previous lessons, but you have deal with real numbers. But here you have to solve this simultaneous equation which has some imaginary parts also, complex numbers also, right? So, yeah, but you have to use the same procedure for this complex number simultaneous equations also, right? We'll see how to get this one. So the first equation is given like 2Z plus IW equals to -1. And the second equation is given like Z minus W equals to 3 plus 3I. Right, so these are the two simultaneous equations that you have. So you can see the variables in our familiar form. The variables are X, Y, Z, like this we have. Right, so here these variables are previous lessons. We have real numbers, but here Z and W are the variables here. They are complex numbers. Right, so in the first part of this question is given that use algebra to find Z, the complex number Z, giving your answer in the form A plus IB, where A and B are real. Right, so we'll see how to solve this one. You know that you can use either substitution method, or there are two methods to solve simultaneous equations. First one is the substitution method and the second one is the elimination method. So you can use one of these two methods to find the Z complex number, right? So the first equation is, we are discussing the second question. First equation is 2Z minus I, plus IW equals to minus 1. This is our first equation. And the second equation is Z minus W equals to 3 plus 3I. This is our second equation, right? So, give me 1 second. Right. So here you can see you have two variables like Z and W, right? So here we have to find this Z. අපිට කියන්නේ Z හොයන්න විතරයි. සාමාන්‍ය අපි simultaneous equations දෙකක් solve කරනවා කියන්නේ variables දෙකම හොයනවා. නමුත් මේකෙදි අපිට කියන්නේ Z ව හොයන්න විතරයි. Right? So in this one you can see you can use any of method, right? So first I will show you how to use the elimination method here. So you can see in the first equation you have IW term plus IW term. So second equation you have minus W's term. So when you are multiplying the second equation by I, you can form the term minus IW here. Then you can add these two equations and these IW terms can be cancelled out and you can go for the answer with Z, right? So this is the thing that I have do here. I multiply second equation by I, right? So the second equation is Z minus W equals to 3 plus 3I. So I multiply this one by I. So we can we have Zi minus Wi equals to 3I plus 3I square, right? So this is our third equation. Right, so you know that since this is 3I square, so we can simplify this one as further also, right? So I square is equals to minus 1, right? So we can write rewrite this one as Zi minus Wi equals to 3I minus 3. So actually this is our third equation. So by using these two equations, this equation 1 and equation 3, you can add these two equations and go for the solution. Now I add equation 1 and 3. So 2Z plus here Zi plus Zi. Here, this IW and minus IW is cancelled out in this term, in this side. So here in left-hand side, right-hand side, we have minus 1 and plus 3I minus 3. So by you have to find this Z. So we are writing this one as 2 plus I. We can take this Z as a common factor from this left-hand side, and also we can simplify this one as 3I minus 4. Right, so for Z, we can solve for Z by 3I minus 4 divided by 2 plus I, right? So actually in the question it is given that you have to keep the answer in form of A plus IB. May form eකට convert කරන්න ඕනේ. So what's the thing you have to do is you have to multiply both denominator and the numerator by the conjugate of this denominator. So our denominator is 2 plus I, conjugate of this denominator is 2 minus I. So I'm going to multiply both sides, both up and down, 2 minus I, right? So by here, we can simplify this one here, 3I into 2, it is 6I. 3I into I minus I, it is minus 3I square, and minus 4 to 2, it is minus 8, and minus 4 into minus I, it is plus 4I. divide by, so here you can see plus 2 plus I and 2 minus I, so we can get the value 2 square minus I square. So 2 square is 4 minus 1, so it is 5. So our denominator is 5 here, so we can get the result like this. 6i and 4i can be taken like 10i. So you know that since this is a, here we have minus 3 items, so this one becomes minus 1, I square is minus 1, so we can get the result plus 3 minus 8 here, so it is equals to 5, right? So it is equals to 5 divided by 5. So you can get the result by simplifying this one. I will write this one here, right? So we can get this Z value as by dividing this one by 5, 2i plus 1. This is the Z value, right? Is it clear how you get this Z value? Give me 1 second to drink some water. Now, is it clear how to get this one? This is how we use eliminate, how you use the elimination method to solve this quadratic equation, right? Sandhika is saying clear. What about others? Give me 1 second. Right. Others are also saying this, so I think this simplification is okay. As well, you can use the substitution method also, right? So I will give you the same same answer with this method also, right? So, right. Our two equations are simultaneous equations are 2z minus I, sorry, plus IW is equals to minus 1. It is first equation, and the second equation is z minus W equals to 3 plus 3i, right? So this is the second equation, right? Nimasha is asking minus 5 or plus 5. This plus 5, Nimasha. Nimasha is asking this one is minus 5 or plus 5. It is plus 5, Nimasha. Here you are asking this one. 2 plus I and 2 minus I. Right? So when you simplify this one, Nimasha, 2 plus I, 2 minus I. Right? So you have to take 2 square minus I square. So 2 square is 4 minus I square is minus 1. So it gives you plus 5. Where Nimasha? Oh, right. Yes, this one is, yes, Nimasha, you are correct, right? This one is minus value, minus 5. This is minus 5. Thank you for pointing out my mistake. So this one is 2i minus 1, right? 2i minus 1. Is it clear? Okay, you are welcome. And so our Z is 2i minus 1, right? Yeah, I had a mistake here. 10i minus 5 divided by 5. So it is given like 2i minus 1, right? So when you take the next one, that means I'm using the substitution method for this one. That means from equation 2, we can easily subject W here. Right? From equation 2, I am subject W. Mama W ko ukta karana. Right? So we can write this one as Z minus 3 minus 3i is the W. This is the way how we subject W from the second equation. So after subject W, we can easily substitute this W value for this first equation. So 2Z plus I, instead of this W, we are using this one, right? Z minus 3I equals to -1. So we can simplify this one now. 2Z plus IZ minus 3I square equals to -1. Right, so we can simplify this one as 2Z plus IZ minus 3I plus 3 minus 1. So we can simplify for Z here. 2Z plus IZ equals to 3I minus 4. That means we are taking this plus minus 3I to right hand side as plus 3I. This plus 3 as minus 3. So we can take this one as -4. So we have to take Z value here. 2 plus I equals to 3I minus 4. The same result is come with this one also. Square root Z is equals to 3I minus 4 divided by 2 plus I. Right, so here you have to keep the answer in the same format, A plus IV format. So I'm going to multiply this one by here. So multiply both sides by the conjugate 2 minus I. So you can get the result by the same result you can take here, 2I minus 1. This is the result. Right, so I'm not going to doing these things because I want to show you at this moment the to solve the simultaneous equations. We can use the substitution method also. Right, okay, then this part is over. We'll go back for the question. The part B is saying that calculate RPZ given your answer to 2 decimal places, right? So you have now, by solving these two simultaneous equations, we have found the Z value as 2I minus 1. So in the part B is asking to find the arc value of this complex number, right? So our complex number is 2I minus Z, right? We are discussing the part B now. Z is 2I minus 1. So we can show this complex number in a Venn diagram. It's not a Venn diagram, sorry, Argand diagram, right? So this one is real, this one is imaginary axis. So our complex number is -1 plus 2I, right? The real part is -1, right? -1 plus 2I. So this one is 2. So this is our complex number, right? This is Z -1, 2, right? Right. So we have to find the RBZ here. That means you have to, this is the complex number and you have to take this angle here, right? In order to find this angle, we can use, I will use this angle here. I will take this angle as theta, right? So, so what is the RBZ here now? RBZ is 180 minus theta, because we want this red color angle here. But to get this red color angle, we have to subtract this theta angle from 180. You know that this the half semicircle gives you 180 here, right? So you can get tan theta, right? Tan theta is equals the opposite side, it is 2, divided by the adjacent side, it is 1, right? So theta is equals tan inverse 2. So the tan inverse 2 means the results can be taken as 63.43, right? So this is the theta angle. So you can get the result by 180 minus 63.43. So the angle is 160.757, right? 0.57. So sometimes you can get this angle also. Will you take this one as beta, right, or alpha? Anything you can use, any notation for angles. So when you take this angle as beta, so how you find arc z? Arc z equals to 90 degrees plus beta, right? ඔයගලන්ට එහෙම ගන්නත් පුළුවන්. මොකද අපිට හොයන්න ඕනේ මේ සම්පූර්ණ කෝණය, right? So we can write this one as 90. This angle is 90 degrees plus beta, right? So you can use either one of these two methods, right? So when you put the tan beta here, right? Tan beta is the opposite angle, it is 1, and divide by the adjacent side, 2. So beta is tan inverse half, right? So tan inverse half means we can take beta angle as 26.57. The same answer comes here also, 90 plus 26.57. So the same result is come up with this one also, 116.57 degrees is the arc value. So the same result is come up with the both methods, right? So just use only one method, right? Otherwise you will get more time, right? Okay, then this is the end of the second question. I'm going to go for the third one here. Is it clear? Up to now we have discussed 2 questions. Are they clear? Then we can go for the next one. Here, given that z plus 2i divided by z minus lambda I equals to I, where lambda is a positive real constant, right? So it is given that some expression with complex numbers is given for you. Here z plus 2i divided by z minus lambda I equals to I. So we have, in first part you have to show that this result is z. So you know that in this expression we have z in two positions. So we have to show that this z can be written as like this format, right? අපිට මේ විදිහට ලියන්න පුළුවන් කියලා පෙන්නන්න, right? Okay, we'll go for the solution here. Let me share the whiteboard. Right here, this is the third question we are discussing now, right? So the expression that we have is z plus 2i divided by z minus lambda I equals to I. So we have to find the result. Z equals to lambda over 2 minus 1i plus lambda over 2 plus 1. This is the result we have to prove here, right? So to take this z, we have to simplify this one like this, right? So I'm going to multiply this z minus lambda I term with this I. So we can write this one as z plus 2i equals to I times z minus lambda I, right? So we can remove brackets here, zi minus lambda I square, and here z plus 2i is also there, right? So when you, since you want to find the since there is I square term, right? I square terms, we can take this one as minus 1. So this can be written as zi plus lambda. Z plus 2i is there, right? Is this clear? Since this is minus 1, this minus lambda minus 1, it gives you plus lambda here, right? So we have to go for the z here, right? So I'm going to take this zi for this side. So z minus zi I'm taking this 2i for this side. It is minus 2i plus lambda. And we can go for z. It is 1 minus I equals to minus 2i plus lambda. So we can go for z. It is minus 2i plus lambda divided by 1 minus I. Right? So this is the result for z, but it is not this one. Make a name right? So that means you have to form this complex number z in a plus ib format, right? So what the thing you have to do is you have to multiply both sides, both up and down, by the conjugate of the denominator. Here the conjugate of the denominator is, here denominator is 1 minus I. So you have to multiply by the conjugate, that means 1 plus I, both sides. Right? So after that you can simplify this one. Here you can see in the denominator you have 1 minus I and 1 plus I, right? In the numerator you have minus 2i plus lambda into 1 plus I. So you have to simplify these two. Here as the denominator you have the factors of the difference of two square terms. So it is 1 minus I square. So 1 minus I square. So you can simplify this one as 2, right? So in the numerator, we can simplify this one as minus 2i minus 2i square plus lambda I, right? This is the way how we simplify this one. So here you can see this I square can be simplified as minus 1, as well this I square is also simplified as minus 1. So when you are simplifying these two, and you can end up with the result minus 2i plus 2 plus lambda I divided by 2, right? So 1 minus minus 1 gives you 2 here. So I'm going to use another sheet here, right? So Z is equals, I will write the previous result, right? Minus 2i plus 2 plus lambda, minus 2i plus 2 plus lambda I divided by 2. Plus lambda I divided by 2, right? So we can simplify the lambda I terms and real terms together. So you can write this one as lambda minus 2 I plus lambda plus 2 divided by 2. So we can simplify this one as lambda minus 2. This 2 is common for both terms. So we can write this one as I plus lambda plus 2 divided by 2. The result that we have proved is the same one. You can write this one as lambda over 2 minus 1 I plus lambda over 2 plus 1. Right? So this is the result that we have to prove here. Lambda over 2 minus 1 into I plus lambda over 2 plus 1. So in this case, we have only that means only simplification. Otherwise, there is nothing special in these complex numbers, but you have some long simplification here, right? So we have proved this result. So let me show you the next one here, next part of this question 3. And given also that argz is equals to tan inverse half, right? So in argz is given like tan inverse half, then find the value of lambda and find the value of z modulus square, right? So we see the part B, right? So it is given that argz is equals to tan inverse 1 over 2, right? So here by using this result, since it is given that lambda is a positive real constant, right? So I'm getting the result. I use this result to, this is part B. In part B, it is given that our Z is now we have write that lambda over 2 minus 1 I plus lambda over 2 plus 1. This is the result we have in part A, right? So this one may result ekamai, right? So, and in the question is given in part B that arg Z, right? Arg Z is equals tan inverse half, right? So you can get the arg Z value here, right? Arg Z is, you know that when you are taking the diagram, right? So when I'm taking the common value like x plus iy, right? So Z, so we can take this theta by tan theta can be written as the length is y, this length is x. So we have to take the length means you have to take y over x for this tan theta, right? So here also, this is the y value instead of this one, because y value means the coefficient of this imaginary part. I coefficient එක තමයි අපි y කියලා ගන්නෙ. As well, this is the x part. So by using this one, you can go for this result, because since we don't know the lambda value, we can't draw the exact complex number on this Argand diagram. So I'm going to use this tan theta value. Arg Z is given like lambda over 2 minus 1. This is our y value. Divide by the x value is here, lambda over 2 plus 1. So I'm going to through this simplify this one. So we can go for simplify this one by taking a common factor 2. So it is lambda minus 2, right? So divide by 2. We have to take the common factor here also, so it becomes lambda plus 2, right? So we can take this one as lambda minus 2 over lambda plus 2. This is the result we have as tan theta, right? Tan theta. So in the question it is given that arg Z is tan inverse the half value. So theta means you are taking the tan inverse this value, lambda minus 2 divided by lambda plus 2. So in the question it is given that tan inverse half. So we can simplify these two like this, lambda minus 2 divided by lambda plus 2 is equals to half, right? So you can see we are simplifying, we are equaling these two terms, right? Tan inverse terms together, right? So by using this one, we can solve for lambda. So 2 into lambda minus 2 equals to lambda plus 2. So we can simplify for this one, 2 lambda minus 4 equals to lambda plus 2. So we can go for the result by solving this one as lambda is equals to 6, right? So is it clear for you? Is it clear? Is it clear for you how to get this arg value and how to equal these arg values here like this? The lambda value is 6. Shall I repeat this one again? Is it clear for you? Otherwise, I can go for the next one. In the next part, you have to find the value of modulus Z star. Now you can find you have we have found this lambda value is 6, right? අපි දැනට හොයාගෙන තිනවා මේ lambda කියන්නේ 6 කියලා. So you can write this z value as 6/2 plus 1 plus I into 6/2 minus 1. So we can write the answer here. 6/2 means 3. 3 plus 1 is 4 plus I. 3 minus 2, sorry, 3 minus 1 it is 2. So we can write this complex number z as 4 plus 2i, right? 4 plus 2i. So you have to find the modulus value of this z here, right? So after finding this z, we can draw this value here on a Argand diagram. It is, this one is real, this one is imaginary, right? So this is 4,2 here. This is z. So in the this one we have to find the modulus of z, right? That means modulus of this z. So it can be taken as z square can be taken as 4 square plus 2 square here. So 4 square is 16 and 4 square is 2 square is 4. So we can simplify this one as 20. So this is the z star value here. Is it clear? This is the way how we find this part C. Please hurry up. Can please tell me this finding this lambda value and finding this modulus value is clear for you? Please hurry up. Samadhi is saying yes, right? Samadhi is saying it's clear for her. What about others? Tenushan, is it clear for you? I think yes. Okay. Yasira is okay saying yes. So I think it's clear for you, right? And if someone do not get this thing very well, please let me know. I will explain again. There is no any issue, right? අනිත් තේරුණා කියලා තමන්ට තේරුණ නැත්නම් නොකිය ඉන්න එපා. කියන්න මම ආයෙත් explain කරන්නම්, right? So here we have to go for the next question here, question 4. Right. This question 4 is very easy. Z is given in some format and you have to find z and z square and you have to find the modulus value and the arg z square here, right? So let me show you this one in whiteboard, right? So I will send this whiteboard slides for you, right? I forgot to send these whiteboard slides last week. I promised to Vihanga I will send it because but I forgot this. I'm extremely sorry, right? I will send it today, right? Whiteboard slides ටික ඉල්ලලා තිබ්බා මට ඒක අමතකුණා ඇත්තට මේ වන්න ඔයගලන්ට. හරිද? මම අද ඒවන්නම් කලින් සතිවල ඒවත් එක්ක. Right? So here the z is given like 50 divided by 3 plus 4y, right? So in the first part it is given find the z and z star in the format a plus ib format එකට හොයන්න කියලා තියෙනවා. So z can be found in a plus ib format by multiplying both up and down by the conjugate of this denominator, right? So conjugate means 3 minus 4y. So you have to multiply both sides by 3 minus 4y, right? So when you are simplifying this one, it is 150 minus 200i divided by 3 square minus 16 I square, right? So we can simplify this one as 150 minus 200i divided by here. 3 square is 9. I'm writing this one here. 3 square is 3 square minus 16i square. So 3 square is 9 minus 16 I square is minus 1. So we can simplify this one as 25, right? So we can simplify this one as 25. So we can go for the result for this one as 150 divided by 25 is 6 minus 8i. So this is the same complex number Z can be written here. And as the second part, you have to find Z square, right? So Z square is the, I'm describing second part here. Z, our Z is now 6 minus 8, 6 minus 8i, right? 6 minus 8i. So Z square can be taken as 6 minus 8i square. So you can get the result by expanding this binomial. It is 36 minus, you have to take the twice of this multiplication of these two terms. It is 96i plus 64i square. So instead of this I square, we can use minus 1. So we can simplify this one as 36 minus 96i square minus 64. So we can go for the result as minus 60i, sorry, this one is 96i, right? So it is minus 96i minus 28. So this is the Z square complex number. You know that by taking the square term of some complex number, this also came out with another complex number. So this is the Z here. So when I go back for the question, I will show you what's the next question. So you have to find the modulus of this Z, right? So we have to find the modulus of Z and arg Z square. So you have to find the modulus of this Z and the arg value of this Z square, right? So we'll see this one in whiteboard. Here you have to find, first you have to find arg modulus Z. So you know that Z is 6 minus 8i. So we can draw the same one in a Venn diagram, real and this is imaginary. So when you are taking this one, you can say 6 minus 8i. So this is the Z value here, right? 6 comma minus 8. So you have to find the modulus value of this one. That means you have to take the square terms of this one. So when you find the Z value, so we can find this one as 6 square plus 8 square. So we can simplify this one as 36 plus 64. So the modulus values of this one is come up with square root 100. So it is 10, right? So this is the value of modulus Z. And we will go for the next one. Here you have to find the arg Z square. Z square is this complex number. So you have to find arg Z square, right? So let me share this one in next slide. So here Z square in part C, I think, right? Z square is asking, it is 96i minus 28. So this is the complex number we have, and we can draw it in on a Venn diagram here. This one, this is real part and this is imaginary. So all two are minus here. The real part is minus 28 and the imaginary part is minus 96, right? So this is the complex number we have, right? Z square, right? So we can you have to find the arc Z star. That means you have to find this result, right? This angle here. So you can use one of these two angles to find the result. So I'm using this angle. I will take this one as alpha, right? So by considering this triangle, I can find tan alpha here, right? Tan alpha is the opposite angle, it is 96, opposite side, and the adjacent side, it is 28. So we can find tan alpha like we can simplify this result as 24 divided by 7, right? So we can go for alpha is equals to tan inverse 24 divided by 7, right? So it is the answer for alpha is 73.7. This is the alpha value. So in order to find arc Z square, so you have to take the whole angle. That means you can add 180 plus this alpha. So you can substitute alpha for this one, 73.7. So you can end up with the result 253.7. So this is the arc value of Z square complex number. Right, so is it clear for you? Now I'm going to wind up this tutorial session for today. We will discuss other questions on next week, right? So we have 10 questions in this tutorial. So I will upload this one. I will send to the Gaia madam and she will upload this one on LMS, right? So you can get this one and practice other questions also, then you can verify your solutions when I'm discussing the remaining questions next week. So we have discussed 4 questions up to now. Are there any questions? Are there any questions up to now? Okay, I think you haven't any questions, right? So if you have any questions, please send me via WhatsApp or email. Sometimes I am busy, so sometimes I can't. Anushka is saying all clear. Thank you very much, Anushka. Okay, you are welcome. You are welcome, Tanisha. And I'm going to stop this one here. And thank you very much for attending the lecture, attending the tutorial session for today. And thank you very much. Have a nice week. Study hard and stay safe. Thank you very much, everyone. Okay, I'm ending the meeting now. You all are very welcome.